Hello friends, I welcome you in lecture number 3 on logic. In previous two lectures we have discussed about propositions and we have also discussed three logical operators which were negation logical operator, AND operator and OR operator. And for OR operator we remember that we are considering inclusive OR, and for exclusive OR we are using this operator. And in this lecture we are going to discuss one more logical operator which is called implication or conditional statement. We will understand what is this implication logical operator and what is its truth table, and we will see some examples of implication also. So before writing the definition of implication, we understand with the help of this example. So I have taken this statement: if I am elected, then I will lower taxes. So you can see here we have two statements which are combined. We can consider this statement: if I am elected, suppose I denote this by small p, then I will lower taxes. Suppose this statement is denoted by Q. So we have this type of situation: if P, then Q. So this type of statement is called conditional statement or implication, and it is denoted by this symbol P2Q, or P implies Q. If P is true, then Q is also true. If this happens, then we can say that this promise is valid. If I am elected and if I will lower taxes, then I have made my promise, and if I am elected and I am not lowering the taxes, then my promise is failed. So it is like this type of situation, conditional statement. So whenever we are having this type of conditional statement, we are interested in the truth value of this implication or conditional statement. So for that, first we understand in this way. Suppose I am writing P here, Q, and I am interested in the truth values of this implication P to Q. So as we know, for P we have this type of possibilities, TF, TF. This type of possibilities are there for two propositions. Now we understand with this statement, that is, if P is true, that is if I am elected, then Q is also true, that is I will lower taxes. So in that case, if P is true implies Q is true, then I have made my promise, therefore this is true. P implies Q is true. But if I am elected and I am not lowering the taxes, that is if P is true but Q is false, in that case I am breaking my promise, therefore this implication is false, therefore I will write F here. So these two cases are very clear. If I am elected, then I will lower taxes. So P is true implies Q is true, therefore this conditional statement is true. For second possibility, if I am elected but I am not lowering the taxes, in that case I am breaking my promise, therefore this implication is false. Now what about these two situations? Here P is not true, that means I am not elected. So if I am not elected, then there is nothing to discuss with this statement. This statement is for this condition, that if I am elected, then I will lower taxes. But if I am not elected, then whether taxes are lowered or taxes are not decreased, that is not the concern, because this P is not true. So in that case, we cannot say that this promise is breaked by me. So whenever P is false or P is not true, we cannot say that this promise is a break. Therefore, in that case, we will assign truth value T to this conditional statement. If I am not elected, then whether taxes are lowered or taxes are not lowered, that is not breaking this promise statement P implies Q. This promise statement depends on this condition that if I am elected, then I will lower taxes. If I am elected, then and I am not lowering the taxes. But in the case that P is false, then we don't worry about the truth value of Q, and we consider this implication to be true. So this is the definition of conditional statement, that P to Q, this is true in these two cases whenever P is false, and it is true if P is true and Q is true. So it is false only if P is true. If P is true and Q is false, in that case only this conditional statement is false. So remember this implication. They can ask you to write down the definition also. Let P and Q be propositions. The implication denoted by this symbol P implies Q is also a proposition that is false when P is true and Q is false, and true otherwise. Whenever P is true and Q is false, then only P to Q is false. In all other cases, implication is having true value. And in this implication P to Q, P is called hypothesis, and these are two other names also, and Q is called the conclusion or consequence. And this implication is sometimes called a conditional statement also. And in normal language, in all these situations, we have this conditional statement P to Q. So we can understand this P to Q in all these situations. We are going to use this conditional statement. First one is Q is necessary for P. When we are writing P to Q, that means Q is necessary for P. Another situation is P is sufficient for Q. Q is necessary for P, that we can understand again with this example also. Here Q is I will lower taxes, P is I am elected. So for me to make Q here true, I will lower taxes, it is necessary for me that I must be elected in that sense. And P is sufficient for Q, that is to lower taxes, it is sufficient for me that I am elected. So these are the different ways of writing the same conditional statement. We can write Q if P, that is if P is true, then Q is true. P only if Q, and P implies Q. So whenever we are translating English sentences into conditional statements, then we will remember that in this type of situations we are going to use implications. Here I have taken one example. I have this sentence in English language, and that I have to write in symbolic form using the predicate logic. The statement is the crop will be destroyed if there is a flood. So we can see that this we can rewrite as if there is a flood, if there is a flood, then the crop will be destroyed. The crop will be the same statement can be rewritten in this way also. So now to write down this in symbolic form, we can see that here I have two statements, that if there is a flood, second one is the crop will be destroyed. So we have this type of situation here. P implies Q. If P is true, then Q is true. So we can write that P as there is a flood. We denote this statement by P, and Q is the crop will be destroyed. And therefore given statement in symbolic form is this implication, P implies Q. So in this way we can write, or we can translate English sentences into symbolic form also. Now we can have conditional statement on two-sided also. This is one-sided conditional statement, P to Q, that is P implies Q. But suppose we have Q implies P also. In both the cases, P to Q and Q to P, that is P implies Q and Q implies P, both are true, then we have this situation biconditional statement, that is P if and only if Q. If P is true, then Q is true. If Q is true, then P is true. So in this situation, if both the propositions have same truth value, then only this is going to be true. That is, if P is true and Q is true, then biconditional is true. Now because if and only if P is false, then Q is also false, but truth value will be T. And if we have this type of opposite truth values, then in that case biconditional statement is false. So that is definition of biconditional statement. Let P and Q be propositions. The biconditional, denoted by this symbol double arrow, is the proposition that is true when P and Q have the same truth values and is false otherwise. So we can say that the biconditional is true precisely when both the implications P to Q and Q to P are true. Because of this, the terminology P if and only if Q is used for this biconditional, and it is symbolically written by combining the symbols, these two symbols. If we combine these two symbols, then we have symbol of biconditional, and that means P if and only if Q. So whenever we have this type of sentences, we can understand that we are going to use biconditional operator. P is necessary and sufficient condition for Q. If P is true, then Q is true, and conversely, that is, if Q, then P, and P if and only if Q. This is one situation in which we have biconditional statement. You can take the flight if and only if you buy a ticket. So suppose this is denoted by P and this is denoted by Q, and suppose we are writing the truth table for this biconditional statement, then we have this type of four possibilities for P and Q. Now first one is P is true and Q is also true. That is, you can take the flight implies you buy a ticket, and if you buy a ticket you can take the flight. So this is also true. Here P is true, that is, you can take the flight is true, and Q is false, that is you cannot buy a ticket. So this makes this wrong. Similarly, this is false here. Here I have to write false F. So if one of the two propositions is false, then biconditional is false. And what about fourth situation? You cannot take the flight, and Q is you cannot buy a ticket. So that is fine. If you cannot take the flight implies you cannot buy a ticket, and you cannot buy a ticket implies you cannot take the flight. So in that situation, here we have truth value T. So biconditional is having truth value T if both P and Q have the same truth values, either both are true or both are false, then biconditional is true. And biconditional is false if at least one of P and Q is false. And we again recall for conditional statement, that is one-sided condition. Here we have this type of truth table. Here what we will remember, that this implication is false if P is true and Q is false. So here I write F. In all other situations I will write T. If P is true and Q is false, then this implication is false. In all other situations it is having truth value T. So remember all these definitions of all these logical operators. Now we have negation logical operator, and, or, exclusive, or, conditional, and biconditional. So we are going to use all these connectives throughout this lecture series. So you must be familiar with all these logical operators, their definitions, and how to write down truth table for them. And using this knowledge we will proceed further in upcoming lectures. Thanks for watching.